Welcome back. Here's a second example for section 7.4. Number 20. The Bureau of Labor Statistics reported in a recent year that 5% of unemployed adults in the United States held multiple jobs. I think it's higher than that, but okay, 5%. A random sample of 75 employed adults is chosen. Okay, so 5% of employed adults, that's a statement about our population. And so that's our P equals 0.05, and then a sample, random sample of 75, that's N equals 75. So letter A, is it appropriate to use the normal approximation to find the probability that less than 6.5% of the individuals in the sample hold multiple jobs? If so, find the probability. If not, explain why not. So this is it appropriate part. That's where we need to check NP, see if that is greater than or equal to 10. And then also we have to check N times the complement, 1 minus P. Is that also greater than or equal to 10? So let's do that. N times P would be 75 times 0.05. Uh-oh, that's only 3.75. This is too small. It needs to be at least 10. So it's not appropriate. We do not have the tools because we don't know that this is a normal distribution. We just stop. All right, so we go on to part B. A new sample of 350 employed adults is chosen. So now we've got a nice big N. Find the probability that less than 6.5% of those individuals in that sample hold multiple jobs. So I'll do just a very quick check. So when I do the two multiplications here, NP is 350 times 0.05 is 17.5. That is now big enough. And then N times the complement would be 350 times 0.95, 1 minus the 0.05, and that's 332.5. So those are both fine. So now we can address the question. We can draw a picture if we want. So we've got our normal distribution because we've got a big enough sample size. The population p-value, 0.05, goes in the middle. And 6.5% in the problem, we convert that to a decimal, and that becomes 0.065. So 0.065 will be a little bit bigger than 0.05, but we're going less than that. So that will be to the left of that point. So we want to find that area. So the probability that a sample proportion is less than 0.065 would be normal CDF. Let's see, the left boundary would be the negative 10 to the 99, right boundary 0.065. And then remember, for the mean of the sample proportions, we use the population P. So that's going to be 0.05 from the original problem. And then for the standard deviation of the sample proportions, that's going to be that big square root of, let's see, 0.05 again, times the complement, 0.95, all over our bigger sample size of 350. So that's what we'll put into the calculator. And after rounding, I get 0.9011, which makes sense. It's more than a half. So it's reasonable. My drawings are rarely to proper scale, but there we go. All right, a couple more parts to look at. Find the probability that more than 6% of the individuals in the sample of 350 hold multiple jobs. So our standard drawing, 0.05 in the middle. That's going to be in the middle of all our drawings for this problem. And now we're going larger than, greater than 6%, which is 0.06. So 0.06 somewhere to the right, probably not very far to the right, but then we're going even more than that. So the probability that a sample proportion is more than 6% or 0.06 would be normal CDF. Now we're starting at the 0.06 and going to the right. So 1006 up to positive 10 to the 99. Then our P of 0.05, and then that big square root, 0.05 times 0.95, all over 350. I hope you write all this out on your paper. Practice writing it out so that you're comfortable with it. So when we actually do this in person, or on a test, I should say, you'll be ready. It won't be too strange to do, not too much to think about. So as I work this out on my calculator, I got 0.1953, which makes enough sense. It's less than 0.5. That's about as accurate as I worry about. More than 0.5 or less than 0.5, and that's less than half. All right, find the probability that the proportion is between 0.05 and 0.10. So here's our picture, 0.05 in the middle. And 0.10, that's a fair distance away, so I might draw it further down the line. But we're looking at the area between those two numbers. So using the notation, if you want to, 0.05, sandwiching is less than p hat, less than 0.10. That's going to be normal CDF. 0.05 to 0.1 or 0.10, either way. 0.05 is also the mean, and then that big old square root. Almost the last time we have to write that down. All right, remember you can always just pause the recording. I actually am while I go use my calculator. But now this number, let's talk about how to round it. Let me write it down. It's 0.49999, and then some ones and so forth. And if we want to round this to 4 places like we've been doing, we're going to have to round up, and then up and up and up. It's going to end up rounding to 0.5000. Rounded. Did I say enough zeros? So that's kind of tricky. So we're rounding to 4 places, and that makes us show all those zeros to show that it's that accurate. Interesting. All right, last question. Would it be unusual if less than 4% of the individuals in the sample of 350 held multiple jobs? So 4%, that's our 0.04. And then unusual, remember that's if our answer is less than 0.05. So a lot of 0.05s living around in this problem. Pay attention, try not to get them messed up. We draw our same drawing, 0.05 in the middle, and we're looking at less than 4% or 0.04, so a little bit on the left. This actually might not be different. It might be the same as the 0.06. If you notice part C, we're sort of doing a mirror image of part C. I'm curious if it might come out to be the same answer. So the probability that p hat is less than 0.04 would be normal CDF down to that huge negative number, negative 10 to the 99, up to 0.04, 0.05 in the middle. One last time for that big old square root for proportions. And then plugging it into the calculator. And yes, I could have saved myself a little work if I recognized that this was the mirror image of number C, letter C. So those in fact turned out to be the same areas. Though we are asked now, that's not actually the answer to the question. Would it be unusual? And so we say, since 0.1953 is in fact greater than 0.05, it is not unusual. Unusual, I spelled that wrong. All right, so I hope that last example helps clarify 7.4 and just put it all together for the exam.